So as we continue through the periodic trends, one periodic trend that is really important has to do with ionization energy. So before we really delve into ionization energy, we should talk about ions and what exactly ions are. You've definitely talked about ions in previous science classes, but we really want to get our vocabulary clear before we start talking about ionization energy. So what is the definition of an ion? An ion is an atom with a charge. And how does an atom get a charge? Well, that means that it has an unequal number of protons and electrons. Now, the number of protons in an atom isn't going to change. That would change the identity of the atom to a different element. That's also what a nuclear reaction is. So in everyday chemistry, the number of protons in an atom doesn't change. But what can change is the number of electrons. Atoms can sometimes gain electrons or they can lose electrons. And they always do this in order to have that full outermost energy level. When an atom has a full outermost energy level, it is the most stable. So it can either gain electrons or lose electrons. We have different names for positive and negative ions. So a cation is the name for the positive ion. And how does an atom become positive? Well, that must mean it has lost an electron. Because it has lost an electron, it now has more protons than electrons. Protons are positive, so the ion is positive. And if an atom gains an electron or electrons, then we call that ion an anion. An anion is going to be negative because now there are more electrons than protons. And if you look at the pictures on the right-hand side of the page, you can see the model of an atom gaining electrons and becoming a negative anion, or an atom losing electrons and becoming a positive cation. And also a fun little mnemonic way to help us remember which ones are positive and which ones are negative, right? Cats have paws. Cations are positive ions. And so now let's talk about ionization energy. So this is going to be the energy needed to do something, since it's energy. It's the energy needed to make an ion. And you can become an ion by gaining or losing electrons. But ionization energy is specifically about losing electrons. Ionization energy is the energy needed to remove an outermost electron from an atom. And even if an atom is stabilized by this, it's still going to require energy, because those electrons are negative, the nucleus is positive. Those electrons are attracted to the nucleus. So if we're going to, or if an electron is going to be pulled away from that nucleus, energy would need to be added in order to overcome that attraction. How much energy needs to be added is a function of how much attraction is needed to be overcome. You can see this picture right here. We have an aluminum atom. It's neutral because there's the same number of protons as electrons. Then ionization energy is added. An electron is removed. Therefore, ionization energy is required. Right? This electron is attracted to that nucleus. So in order to remove the electron, I need to add that energy. And now you can see we have an aluminum ion. Its charge is 1+ because it has one more proton than an electron. So what is the trend in ionization energy? Well, you can look at, here's a little sample from the periodic table, right? And if we look at the ionization energy as you go across from left to right, you can see that it may not be completely the pattern all the way across, but in general, ionization energy increases as you move from left to right. And then if you look going down, ionization energy decreases as you go down a column. So now let's start to think about why, right? Ionization energy increases from left to right. Think about what we were talking about when we talked about atomic size. As we move from left to right on the periodic table, the electrons are in the same energy level. And we said that that effective nuclear charge increases. Same shielding, more protons, the effective nuclear charge increases. So the electrons in neon are very attracted to the nucleus, as opposed to the electrons in lithium. Therefore, it takes more energy to remove those electrons. So let's think about how we can describe that, right? Ionization energy increases from left to right because electrons are in the same energy level. Right? Electrons, as we move from left to right, are in the same energy level, which means the shielding is constant, but the number of protons is increasing, which means Z effective is increasing, which means the electrons are more attracted to the nucleus, and it's going to take more energy to overcome that attraction. And we can see very opposite things are happening as we go down. The electrons are in higher energy levels. Shielding is constant, Z effective is relatively constant. So what is changing, remember the other piece of Coulomb's law, is the distance between the outermost electron and the nucleus. And as the distance between the outermost electron and the nucleus increases, the attraction decreases, and it takes less energy to overcome that attraction. Right? It takes less energy to remove an electron when it's further from the nucleus. So this is the exact opposite of the trend in atomic size. And that's really how I remember it. That I remember the trend in atomic size. So he is small. And then I remember that ionization energy is the opposite of that. That the upper right-hand corner has the highest ionization energies. It takes the most amount of energy to remove electrons from those atoms because those electrons are very attracted to the nucleus.